Okay, this is the lesson over simplifying radicals. I've already started this one, but basically a radical is a square root symbol, so you need to break whatever's underneath the square root symbol down into its prime factors. So we're looking for just prime numbers that will multiply to get 80. So I started with 8 and 10 because that will multiply to get 80, but neither of those are prime, so you have to keep breaking them down. So 8 breaks down to 4 and 2. Now 2 is prime, so we can circle it because that can stop right there. But 4 can break down to 2 and 2. 10 can break down to 5 and 2. So I'm going to write all our prime numbers under the radical. We have 2 times 2 times 2 times 2 times 2 times 5. Then I'm going to break down p to the third into p times p times p. Now the whole point of this is that you want to take any pairs and put them outside the radical. Because if you have like a pair of 2's, that's like 2 squared. And if you're taking the square root of 2 squared, it's just 2. Because the square root and the squared cancel each other out. It's also like 2 squared is 4, so it's kind of just like taking the square root of 4. So the square root of these two 2's is just a 2 on the outside of the radical. Then we can take these 2 out, and they're going to be outside the radical. Now the 5 can't pair with anything because we don't have another 5. P can pair with P, and it can come outside the radical. And then anything that didn't pair up gets left inside the radical. Now all of this is being multiplied, so anything that comes out gets multiplied together and anything that stays inside gets multiplied. So 2 times 2 times P is 4P, and 5 times P is just 5P. And that is your answer. So I like this example because it will show you a trick. Anytime you have a pair of anything, you can bring it out. So if I break this down to 8 and 8, that's a pair of 8's, and I can go ahead and take that out. It doesn't have to be prime if you get to a pair. So we don't have to break it down all the way to a bunch of 2's. In the same way, if we broke this down to 16 and 4, and then we broke this down to 4 and 4. Now, if you hadn't seen the pair at the beginning, you could take out this pair, but you'd still have to break down this to 2 and 2, and then you can take out that pair. Either way, you're bringing out an 8, because if you brought out 1 4 and 1 2, they'd multiply together and get an 8. So let's just do it that way, where we have a pair of 2's and a pair of 4's. Even though they're not broken down, they're still a pair. And then an M 3 times and an N 3 times. Gotta make that longer. So we have pair of 2's, pair of 4's, pair of M's, and pair of N's. Oh, sorry. So we have a 2, a 4, an M, and an N. And left over we have an M and an N. So we get 8Mn on the outside and Mn on the inside. And that's your final answer. Okay, now the only way this one changes is when there's a number out here, anything you bring out will also be multiplied by this number. So if we break down 96, that's 8 and 12. Neither of those is prime. So we keep going. 8 is 4 and 2, but 2 is prime. 4 is 2 and 2, that's prime. Now had we done 12 first before continuing with the 4 and we saw this pair of 4's, we could have stopped there and gone ahead and brought it out. But since I kept going, I'm just going to keep on writing all these pairs. So we have a 7 out here. Inside we have 5 2's. And a 3, and then 3 M's. So if we make pairs, we've got a pair of 2s, a pair of 2s, and a pair of m's. So don't forget this 7's already out here. I'm going to bring out a 2 and another 2 and an m. Then I'm going to leave my 2, my 3, and my m right there. So we end up with 28m on the outside once you multiply those together. Then 2 times 3 is 6. You get 6m on the inside. Now this is one I'd like you to try on your own. You can pause the video and try it and then check your answer with mine. But I would break this down to 4 and 2. This is 2 and 2. So we have a 2 out here. In this step where you write the whole thing out, you don't really have to do that. I just do it because it helps people see it. But once we do these more often, you'll see me not write that. 3 Q's and an R. Pair of 2's, pair of P's, pair of Q's. So we already have this 2 out here. I'm going to copy that down. Now I'm going to bring out this 2, this P, this Q, and then inside we have a 2, a Q, and an R. So you get 4 PQ on the outside when you multiply them together, and 2QR on the inside. Okay, I would write this down somewhere on your notes. Radicals behave a lot like variables, so if you think of a radical like an x or a y, it may help you. So when we're adding and subtracting radicals, which is what we're doing on this next part, you can only add them together if these are exactly the same. This is like having negative 3x minus 4x, and you solve it just like that. The radical won't change, you just deal with the coefficient, which is the number in front of it. So if you solve this, you'd get negative 7x. So just like that, that's negative 7 radical 17. This is your answer. So just like variables, if you have just an x, remember we imagine there's a 1 here. It's an implied 1. So if I just had a radical 17, you imagine there's a 1 out here. So if I do radical 17 plus 2 radical 17, that would equal 3 radical 17, because there's that imaginary 1 out here that you add with this coefficient. That only works if your radicals are the same. So on this one, they're not the same. We cannot put those together. It does not matter if the outside number is the same. So what I would do is see if we can simplify it. So if we break down 6, we get 2 and 3. There are no pairs to bring out. So you cannot break that down, so I'm just going to bring that down here. 2 radical 6 cannot be broken down. Then we have minus this. Let's try to break 24 down. We get 6 and 4, 2 and 2, 3 and 2. So we already have this 2 out here. Now we can bring out another 2. And then we have a 2 and a 3 left on the inside. So you get 4 radical 6. So this right here is the exact same as this right here. They just look different. This one is the simplified version. So if you have 2 radical 6 minus 4 radical 6, it's like having 2x minus 4x. This would be negative 2x. So very similar to that, this is negative 2 radical 6. All right, this one cannot be broken down. 2 is already primed, so I'm going to bring that down here. I'm going to try to break down this 20. I get 4 and 5, 2 and 2. So I can bring out a pair of 2's. So I've already got a 3 out here. I'm bringing out a 2, and I have a 5 left over. So you use the same sign. It's going to be a plus, and that's going to be 6 radical 5. And these, if it were just this, we couldn't do anything. That would be our answer. But we still have this up here. So I can break down this 8. Now remember, this one's going to be minus. So 8 is 4 and 2. 4 is 2 and 2. So I have a 3 out there. Now I'm going to bring out a 2. And I've got a radical 2. So 6 radical 2. So that's a radical 2, that's a radical 2. This is nothing, so we can't combine that with anything. I mean, it's a radical 5, but it's nothing that matches. So a negative 6 and a negative 3 are what we combine or add together. So that's a negative 9 radical 2. This is the last one I would like you to try for yourself, so if you'll pause it and try it, and then you can check with my answer. You can break down this 27 to 9 and 3, and then 3 and 3. So you can bring out a pair of 3's, and you have a 3 left over in the radical. So you essentially have 3 radical 3 minus 3 radical 3, which some people write as 0 radical 3. But 0 times radical 3 is going to be just 0. So this is not wrong, it's just not simplified. Your answer is actually just 0. Now, if you just put radical 3, remember, that's like a 1 radical 3. And that doesn't work. If it were 3 radical 3 minus 2 radical 3, that's when your answer is just radical 3. But that's not the problem we're solving. So the answer here is 0.